So we have Danish Khan and Jitendra Wadle from EDB, whose topic is Run PostgreSQL the Kubernetes way. In this session, they'll cover day 0 to day 2 operations and how data on Kubernetes is more important these days. So let's welcome Danish and Jitendra onto the stage. Guys, it's almost the end. Let's cheer up.
A very good afternoon. So today I am here to talk about running PostgreSQL the Kubernetes way. Myself Danish Khan and with my colleague Jitendra Wadle, we will talk how important it is to discuss about why we want to run actually database on Kubernetes and why it is ever evolving with the evolution of Kubernetes. Okay? Yeah, so these are my credentials. I'm a CKD certified, VMware enthusiast, VMware certified, and you can scan me and connect me on LinkedIn. So you can find more details about me on my social credential with just a scan. So switching to the topic now again. So here we are going to talk about day 0, day 1, day 2 and conclusions. So right from why it is important, why run database on Kubernetes. So we'll talk about all of those and some operations, how to build the PostgreSQL database with one master and 2 replicas, and then go ahead and see the operator capabilities, what we have built with the CloudNativePG. Okay, so one of our speaker mentioned about solving problems, right? So ever since the Kubernetes was evolving, there were like lot of problems which Kubernetes going to solve, right? But there are a lot of which it will not, right? So one of the opportunity was in database domain. Now DOK came into picture, data over Kubernetes. They came into the picture, they started. So in 2009 and more storage vendors came into picture and they started integrating capabilities of storage into the Kubernetes. Then DOK found that we lack databases on Kubernetes. So they started doing a surveys and started educating people why we need it. And like this is an opportunity where we can actually own everything. So why we need it? So like in this survey you see it is ever growing. Kubernetes is ever growing. Everyone is adapting to it. Like all the database workloads are at that time it was like, or right now as well, it is outsourced to somewhere else. So you run database somewhere else and you do something here, right? Like we do usually on a like database critical systems. But with this CloudNativePG, we are going to change everything, right? We are saying everything is a workload, even your database, right? You go and deploy along with your microservice, right? You are deploying an application. Why you are going outside your network to connect somewhere else, right? You can actually build a 3-layer application which includes your database right there on your Kubernetes environment. That's where we came into the picture. And then people like Crunchy Data and Stalon and a lot of people were trying a lot of things along with us. We also evolved and we built something like them. And like we are growing. So ours is when DOK came into the picture, they started growing the community data on Kubernetes, and then we came and built the operator. So this CloudNativePG basically is built and open source by EDB, and we are a CNCF sandbox applied software partners, and then we have also done this certification, Apache license open source it. Now it is in the community. The IP is given to the community to develop and build everything. And if you want to learn about why data in Kubernetes, you can actually go and scan and learn the talks given by a lot of people why we want to run data on Kubernetes. Like one example I said, you have a microservice running in the Kubernetes infrastructure, and then you can go and attach your database over it. So that way you don't have to go anywhere. Have a good database over there running and along with your application. That's it. The loop is complete. You don't have to go outside of your network for that matter. Only thing is that someone coming from outside accessing your application. That's it. Right? Yeah. And yeah, so having said that, these all been adopted by DevOps model. This whole thing has been taken care by applying DevOps model. And like in the DevOps model, what we say, the developer will come and he will start a branch, create a branch to develop something. Then it will go and use the version control systems like tools like Git and all, right? And then he will test something on that, unit test, shift left testing. And then he will test again further, E to E, right? And then comes the reviewer, right? First reviewer, second reviewer, like that. So whole cycle will be like that. This is the overall DevOps model which CloudNativePG has adopted. And it is very important in this ever-growing and fast world, Kubernetes world, where you want to do a proper modeling to release a software, right? So if you see, this whole cycle is like that. Developer, reviewer, testing, everything is happening and it is releasing. So that's the thing here we wanted to talk. See. Yeah, and the whole image is built like that only. So every time the image is built, first level of testing and then deep testing, which is called E2E testing and integration test, which is happening on the images, so that we have a very resilient software which is coming up, right? Yeah. So I'll come to the next point where I'll talk more about the operator which we have built. So before that, we are going to talk about why databases like PostgreSQL servers need to be done using a certain way. These are like complex stateful application, you know. So a lot of people are trying the stateful sets and a lot of Kubernetes ways to deploy the databases like PostgreSQL. So we will explain why we went to the operator way and why we built like that. Database is complex, right? So I think till now the stateful sets or the volume expansions, hot volume expansions, it's a critical work to do, right? Now having an operator, having your custom resources, you know, it makes your life easy. And let's come to the point where we said, okay, we will learn about how we build these things, right? Now, on a typical environment, what you will do when someone says, okay, we have to deploy a database, okay, what comes into the mind? Storage, first thing, how fast it is, where it is going to be, networking, right? These all things will come into your mind, right? On day zero. And then the platform, like what type of bare metal or whatever we are going to use, right? What type of environment constraints we are going to apply, right? How many available regions are there? These are some of the topics which we are going to teach ourselves, right? In order to deploy the databases, like any database for that matter, it is going to be the same. And ever since the storage has evolved, we are here to integrate the databases on Kubernetes, right? Yeah. So having said that, it is very important to understand the complexity of the databases. That's why we built an operator, right? So that the life of a DBA is very easy. And the operator which we built is a level 5 operator, CloudNativePG. So you can go and scan and learn about it. It's a very good state-of-the-art operator which is developed and given to the community, where you can quickly spin up one master and two replica setup with write services, read write services and everything. And it is very much tightly coupled with the Kubernetes environment. You will see. You can open that page. Yeah, if you see, we have taken the consideration of what we are building, right? Every aspect of Kubernetes is tightly coupled with the our operator, and it is very much easily possible. Like when we were developing the operator, we thought what Kubernetes is offering, and it is very well integrated with the API, so that there is no decoupling between them. Database is critical. You have to build it like that, right? So that's why if you see every aspect of there, like service connectivity, self-healing, backup restore, and these are the operators which is evolving in observability, replication, and we will talk about some of it. Like first thing on day zero, we talked how it is important to understand what type of infrastructure we are going to use, like what are the parameters of the PostgreSQL. Then we will deploy an operator, then we will deploy one master, two replica nodes, and then we will see self-healing. We will see rolling updates, and we will see volume snapshot recovery. So further we go down that. So yeah, I talked already about CloudNativePG. how it is built, and it's a level 5 operator with all the functions. So recently in the 121, we have released volume snapshot recovery as well, which is very hot right now, like having things spin up very quickly, right? And like I said, the things are very much coupled with the Kubernetes environment. So that's how. And what leverage it is giving you? You are like, it is vendor agnostic. You go and deploy on any Kubernetes platform. You choose your storage. We are giving you power to choose your storage, to choose your networking, anything you choose. You go and deploy wherever possible on the Kubernetes, of course, on a Kubernetes platform, right? And then you like get benefited from these things. Yeah. Day zero operation, like I said, we talked about certain parameters to get into condition like storage, infrastructure, PostgreSQL parameters, and then decide we are going to deploy on what level, right? So these are the things which, like along the way we talked, right? And then, you know, very important is selection of your storage. You have to understand your workloads. You have to understand what type of storage is available, which will be very much coupled with the Kubernetes. And then you go and build it. And beyond that if you go, you have single region, you have multi-regions. If you go on cloud providers, they will give you multiple available region platforms where you can deploy your softwares, right? So you have to take consideration of all those parameters here as well, right? So it is very important to rightfully use and choose the tools which you want to use. That's why we are here to talk about day zero as well. Otherwise, on very first day, if you look at it, okay, this is an operator which is benefiting me in n number of things, but you are missing on n plus 1 number of things if you do not decide on day zero. This is very important, right? So like I said, beyond storages, what type of things you want, connection pooling, you are going outside your network, we are just focusing inside your network, right? And microservice or monolith, what type, everything is supported over there. So very important in the Microsoft microservice thing that you build your application in the same namespace. Either you take the database in different namespace or in the same namespace. Our service is very much capable of doing all the things, connection and all, everything. So yeah, that was about day zero operation. Now let's deploy our operator and see. So I'll just quickly show you the demo, how we deployed it, and it's very easy. We are using kind here, but it can be deployed everywhere. So for the sake of demo, we are using kind, very lightweight, single node, and we will install the operator. So if you see, it's just one YAML file under which everything will be created. So it will go and select. Yeah, so it will be deployed in the declarative way. You see how quickly everything is created, like your RBAC, role bindings, everything. So here. So if you see the namespaces and all, you can see quickly and where it is getting deployed. So like Kubernetes had like given command line kubectl command, so you can use that very well and see your operator is deployed or not. So our operators will be running, and in a second or so, it will be up with the ready state. And then we will see how we can leverage this operator to create our PostgreSQL database using one master and replica. So it will come into mind, why operator, if we can use a stateful set. See, there are a lot of things which as a DBA you have to do. This is very much capable of doing all of those. And one of the major important factor comes into the recovery, which we will talk. So it does all of those. Even we have developed plugins as well, which we will show in the demo. And beyond that, we have authentications as well available, TLS authentication. So we'll show how MTLS is designed over there and how it connects. So we'll talk about all of those. So log management, like I said, observability and everything is there. So we are not missing on anything. You name it, everything is integrated. Missing part. Or if you feel like this is also can be done, go forward, create pull request, and be part of community and grow it to a level where everyone is benefited from it. Okay. Day one operation. So like quickly deploy one master, two replica, and we'll see the YAMLs as well. So I'll start the demo over here and see how it is getting deployed and how quick it is. Even though this is a pre-loaded image, but with the images as well, it is pretty fast. I come from a background where I used to deploy Oracle for like 2 days minimum. See how quickly this one master and 2 replica is getting deployed with this operator. Life has changed so much with Kubernetes in 10 years. With not even 10 years, 6 years, right? See this YAML, right? One just instances, 3 you want, and you define the storage. And there are multiple parameters we can choose, but this is a very basic example. So just apply, everyone is like aware about these commands, right? And you see how it is getting deployed. So even we have integrated the status as well. See, primary is getting set up, right? And which is the primary, even that information is available. So imagine the life of a DevOps guy or SRE or a person sitting somewhere who wants to monitor. It's very easy, right? Creating a new replica. So primary is done, then it goes and creates a PG-based backup and creates a new replica. And within 1 minute or so, everything will be up, right? Instances 2, now the instances are 3 and ready is 2. Now quickly you will see 2 clustered in healthy state, done. Imagine Oracle 2 days, right? Here, in a blink of eye, your database is up, right? What else you want? This is like amazing stuff which we are doing with CloudNativePG. And look at the statuses, different statuses. We built this plugin just for the statuses. What is? Because database is critical. We want to give more insight, more and more insight. So this gives you power to see what is going, how many, if you see certificate states, right, days left until expiration, 90 days. Every detail, whatever is required as a DBA or DevOps guy, whatever is available over there. Even the backup is not configured, you will find, right? Even the backup status you can see. So these are very well integrated. So, yeah, so this was about that. So on day 1, we deployed our 1 master 2 replica. Now we will quickly go and see how these are the YAML which we talked, and like we deployed the cluster. And now what has happened, we already talked. So if you see the animation, this is what happened behind the scene, right? The service was there, read-write service. Read-write service will always integrate with your primary workload, which is appdb1, right? Then MTLS communication happened between 2 and the 3. It will go and connect again. These are all PG. So see availability zones, different availability zones. So everything is connected now. Now the read-only, read-write, everything is ready. Now this is primary, which we saw in the plugin status. Everything is up and we are happy. That was about this, that how it was set up, how cluster was set up. Okay, and not only that, in the background, when you saw the primary and replica was getting created, these all things happened, right? Read-only service, read, write, RO, everything was created, even the secret config maps, everything. Even in the YAML, like we saw the YAML, which was in the example, it was a very basic YAML, but someone who wants Postgres to behave in a certain way, they can even configure the Postgres parameters in the section. So you can go and explain the sections. Every detail of the YAMLs are available in the open source software. Also, if you want a different write-ahead log files, so you create a different wall storage and increase the performance. We have integrated that as well. So you can define your different storage with wall and size. See, both can go parallelly, and your performance of the Postgres SQL will increase. Okay? These are the bare minimum recommendation from us for a better database. Okay? Next. Now we talk about self-healing. So we will understand here what happened, what are the scenarios. So scenario number 1, which I am going to demo, is on day 3 when you deployed, or day 4 or day 10. What is important in database? Availability. Everyone in the market is worried about their recovery, their availability. People are committing 99.99, 19.99999, right? In terms of percentage. But how do you see that it is going to be like that? You test. You see what is there to be committed and what is there in actual, right? So we'll see how many seconds the whole thing was up. So if you see, your primary goes down, Kube API understands, send the signals to operator that your primary is down. It goes and does the voting and make the secondary primary. The most aligned pod a primary, right? That's important. And then goes, switch the services. This is down, this comes up, split brain happens. What I will do, the primary is up. But it goes and resync everything so that no collision happens. And everyone is happy now, right? And we'll show in the demo. In the demo, what we'll see, application inserting data parallelly. 5 connections are there. So we designed a web test just to test the whole system, right? If you see, we will deploy an application, cluster is already there. If you see, we will see the services. So if you see, there is no part of the application which is inserting. We have a database, but we are not inserting, right? So this is the job where we are going to insert it for 15 minutes, right? For the sake of time, we squeeze the time to like 30 seconds or 2 minutes. Now this web test pod is created. The web test service is created. Now we will see the log as well. So we'll create a job which will show you how the data is getting inserted in the application database. Now see the job, so we'll look in the log how soon this data is getting inserted, right? In a minute. Okay, see. So right now 500 was coming because the table was not there, the table which we are going to insert. We'll create a table and see what is happening over there, right? So it will quickly start inserting data over there. So exactly. So we'll create a table so that the application which was inserting data start inserting data into that. So we will go and check the logs again, and you will see everything is happening. And if you see how we prove that we are, so in 4 seconds, the whole database was up. How we see this was up, right? So we go and run some query on the time difference and see what was the time which was happening. So this will give you that in 4 seconds or 3 seconds, the whole database was up, like that. So primary goes down, the service handed over to the secondary one, it becomes primary within 3 seconds. So this is what the beauty of this operator is. Quickly understands, quickly hands over, and quickly follows the whole scenario that it is available, right? And then you go and dig what was happening, do. We did all this self-healing in automated way. And DevOps comes in the morning, sees this was happening, but in the night it was taken care of. So that was, and then you can see what all things are like that, yeah. So that was self-healing, right? So till now, any question in self-healing or cluster deployments, anything, or else if not, we can connect further and we'll see day 2 and onward operations with my other colleague, Jitendra.
Yeah.
We'll talk about.
Yeah. So I think lots of stuffs are covered by Danish. So we have already covered day 1 activities. So now day 2 activities like operations. Operations, next slide. Yeah. Operations. So when we are talking about the operator and database, so we need the automate the DBA stuff, right? DBA stuff, that means our rolling update. We can say the rolling updates. So we have in the Kubernetes we have deployment, right? So we have introduced the cluster resource, custom resource that is capable to deploy or Postgres pod or instance in a way, and we have the introduced that rolling update features that we can see in the demo. Yeah. So quickly we see. Start with. Yeah, that's fine. So we have the cluster is a healthy state. So we just take that is a pods, and we are just checking the status of that cluster. Yeah, there is healthy status, and that the image of that PostgreSQL is 15.2. So we want, or we have the new release or new patch release of that Postgres image, right? And any security patch as fixed. So we want to upgrade that, and we don't want to like the 0 time downtime, right? So we have managed that point, and we are not shut down our primary, right? So we just take like we have created the table that is persist after the upgrade, and once we have yeah, so we just check the cluster is healthy state, yeah, so that is upgrade one cluster, and as we are seeing that image we have in the cluster. Cluster is a custom resource that we have designed to operate or manage or Postgres resources, Postgres pods, and we are applying the patch in terms of PostgreSQL image, and new image is coming, and we want to deploy a new image, and the downtime we can say 0 downtime. So it will, yeah, let's say the one master, one replica, two replicas. So the primary is still up and running. So the traffic is running here, and we are trying to first, that is a replica, just upgrade that, change the image and restart that, because that is a configuration change in some, so we need restart, but the primary is there. So yeah, so pod is initializing, that means a new image is coming up into the cluster, and in the Postgres cluster, yeah, that is running, and now is terminating set, and that within a second we are just terminating the pod 1, pod 2 or pod 1. So all the pods are upgraded quickly, and nothing happen when the primary is up and running. So we are moving the traffic because switching here. So let's say, yeah, the cluster summary. So now we have the new image. So there is nothing in terms of we can say downtime, and the application is up and running all the time, and our patch is successfully upgraded, and yeah, so we are just checking, verify like that is a version is upgraded or not. And one more thing, yeah, that table is there, so there is no data loss. So that is a simple scenario. Yeah, so we have one more scenario, that is the snapshot one. So we quickly, yeah, the slideshow. Yeah. So the snapshot. So volume snapshot is the native feature is provided by the Kubernetes in that is now in the like from 1.20 version. So volume snapshot feature is come to the picture for database applications, right? So the Kubernetes is like provide a way to create an abstraction layer between a distributed system and the cluster specific application. Distributed applications mean in the sense of we have the application like Postgres applications, and we have that like introduce the Kubernetes as snapshot. So we have accommodated that changes, accommodate the feature in our operator. Like whenever new features and new things are coming, it's always because Kubernetes provide the new features in all the releases, something new. So we are trying to accommodate the changes with our operator. We have lots of 3 to 4 options to bootstrapping our cluster, like PG-based backup and from scratch from the PVC, and we have some tools like Barman, that is open source tool that we are also using for the backup and restore. But because Kubernetes is provided the snapshot feature, so we have introduced, we already have the plugin, and we introduce one snapshot command that is a very simple way. So just a flow. We have choosing a replica, that is not choosing the primary. So we are choosing the replica pod and fencing that replica. Fencing means cut off that from the cluster, right? That is stop. Now the cold means that is point in time, the data is there. So we want to take the snapshot from that point of time, right? So that, and after all the things are happen, we unfencing the replica. So nothing is happen, snapshot is come to the as an object in terms of Kubernetes. Let's play the video. Yeah. So we see this. Yeah. That we just show the status of that cluster. Yeah, it is up and running, and we have that all files and cluster is healthy state. We just take the pod is up and running. Yeah, this third one is the replica one, and we are targeting. So just taking, we are creating. Yeah, we just take like it's after the volume snapshot, we have created some tables and data that also replicate, right? So we are just creating one table and just trying to check after the snapshot as a recover, right? So we'll just see. That's quickly, and that is a pod. Yeah, so yes, that is the command. So that is a snapshot, that is a cluster name, which is cluster example we have already deployed, and that is a -c option that is provide the snapshot class, right? So volume snapshot class. So that is waiting, yeah, to be fenced like this third one, and the object is created. So we just get the object, and yeah, so we can ready to use that object, and that is all the PVC and all the data is copied to that object, volume snapshot object. Now we are recovering, so we just passing that name, that is a cluster example, just that ID, that's it, and we just apply, and we have the new cluster that is have the data, right? We can see that, right? This. So that second cluster is up and running. This feature, like we are directly copying all the data from the volume snapshot object, right? And that is creating our cluster. Yeah. So that's our volume snapshot thing we have introduced as recently, and that is in the development. In future, we have this is the imperative wave and declarative wave we can say, and point in time again, but it's we can say that is implementation phase. So we have introduced your early things which we accommodate the Postgres, we can say Kubernetes latest version, which for the storage. So we are always try, like let's see, just we check the data. The data is there. Yeah, that's great. So all the data is copied here. So basically we are introduced as a way which we provide by the volume snapshot, and we are introduced as it is in our operators. So that's the reason we are saying cloud native Kubernetes, the Postgres is the cloud native way. Yeah, I think that's it.
Yeah. So that was, you can scan and find it, you can scan and join us on community and be part of ever growing operator which we are building. Thank you. Thanks for listening out, and thank you KCD Mumbai for giving us opportunity to talk about this beautiful thing. Thanks again.
Jitendra, that is a really great talk, but wait, just wait here, we have to give you something. So I invite Rohit to present Danish and Jitendra with a memento.
Oh, thank you. Thanks.
Oh my God.
Thank you, we are over.
Just wait a minute.